Here's a problem that has to do with the conservation of mass. And notice here that we have magnesium, which is a solid, and it's being heated with dinitrogen. Let's see here, we'll use the eraser. Wow, that's good. Dinitrogen gas, and the product, it says, is magnesium nitride, and it gives a formula for it over here. And don't worry about the formula, we're just saying this is magnesium nitride, and it turns out it's a solid. And what it says is that when we start, we have this much magnesium, and we have this much dinitrogen. So let's put a start line here. Always a good idea to organize things as you think about chemical reactions. What did you have at the start? What did you have at the end? It'll make it easier to think about it. 0.2250 grams of magnesium and 0.5331 grams of dinitrogen. And how much magnesium nitride at the beginning? 0. None. Hadn't been formed yet because this is the start. The reaction hasn't occurred. Okay, now we'll turn up the heat and let everything that's going to happen. And what does the problem tell us about the end? It says all of the magnesium was consumed. So what number do we put under magnesium here? 0. No grams of magnesium left. It was all consumed. But the dinitrogen was in excess. There was more than we needed. And so there was, some of it was used and some was left over. The dinitrogen atoms, nitrogen atoms from dinitrogen, partly end up in magnesium nitride. You can see them in the formula here. And they partly end up unchanged. And what the problem is asking us is what mass of dinitrogen is unchanged. Let it be X. And the problem tells us that we form 0.3114 grams of magnesium nitride at the end. So that summarizes all the information that we're given, and our job is to find X. And we find X by taking advantage of the quantitative information that we're given. First of all, we need to find out how much dinitrogen, or how much nitrogen, is present in the product. Okay? We know that the total mass of the product is 0.3114 grams magnesium nitride. And we know something else. We know that 0.225 grams of that is magnesium because all of it was used. Right? So we're going to subtract here 0.2250 grams of magnesium. And what we end up with, the number we end up with is 0.0864 grams of nitrogen in Mg3N2. Questions there? You comfortable with what we're doing? Okay, this is the total amount that we had, and we know this 0.225 grams of magnesium is all in there, and there's nothing else in there. So the rest of it, 0.0864 grams. Always check my math. My math is undependable sometimes. It's like my hair. Some of it's gone. We're not home yet. What we want is X, and X is how much nitrogen is unreacted. So we had this total amount of nitrogen, some of which of this 0.5331 gram went into the compound. So let's again write down what we know. We have 0.5531 grams of dinitrogen that we started with, and we have just shown that we used up 0.0864 grams of nitrogen in the product. So if we do the arithmetic, we end up with 0.4467 grams of nitrogen that are in the excess dinitrogen. And so that's X. Does that make sense to you? Are you comfortable with it? Question?